అందరికీ నమస్కారములు. సర్వేభ్యో శుభోదయం. Today is a new topic from Gautham Mukherjee ji, Vedic mathematics. We have completed so far 1 month of our coursework, covering many topics, very important topics like Vedas, Vedangas, Upanishads, Dharmashastras, Darshanas, and also Bhagavad Gita, Sanatana Dharma, and Vastu Shastram. So things like that, Vimana Shastram also. Things like these topics we have completed in 1 month. Now we have started with 2nd month of our instructions. And in this month, we'll start with Vedic mathematics, followed by Sanatana Dharma, Veda Samskruti. Then we will go for Itihasas like Mahabharata and Ramayana. Then we will, in between, we will also see Panchangam after Vedic mathematics. On next Saturday and Sunday, we will have Panchangam because the teacher is available only on those 2 days. After that, we will see Puranas for 1 day. Then we will go for some research topics. So now let us start with Vande Mataram by Challa Chittibabu Garu. After that, we will chant Prarthana. After that, I will introduce the speaker to all of you. Okay, let us start with Vande Mataram.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayajasitalam, Sasya Syamalam Mataram, Vande Mataram, Suprajyosna Pulakitayamini, Pullakusumita Drumadala Shobhini, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Now let us request Satyaji to chant Prarthana.
Namaskaram. Let's do meditation for a minute. Ganapati Hawamahe Kavim Kavinam Upavashramastamam ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनशृण्वन्नोतिभिः सीदसादनम् ॐ श्रीमहागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामवित्र्यवतु। ॐ श्रीमहासरस्वत्यै नमः। गुरुरेव गतिः गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे। न गुरोः परमं शिशिरस्मि गुरोः मतिरस्ति गुरो मम पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करं। शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतो वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतं गमय। ॐ शान्ति शान्ति शान्तिः। मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव। ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। श्रीगुरुभ्यो नमः। हरिः ॐ।
ధన్యవాదములండి సత్య గారు. Now I will introduce Gautham Mukherjee ji to all of you. You all know he is, a co-student to all of us. It is only for namesake that he is a co-student. He has been registering for this course right from the beginning and also teaching this subject right from the beginning. That is first course, second course, and this is the third course for him. He just wants to learn anything more than what he has already done. Probably that is the reason he has been registering. There are one or two people like this who are repeating the course in spite of their experts in all the topics. He is MSc in Physics from Burdwan University, West Bengal, 1977, and PhD in Physics from Indian Institute of Technology, Kanpur. And service-wise, he joined National Informatics Center, NIC, in 1990 and retired from NIC in 2016 from the post of a Senior Technical Director. Although all through he is interested and tried to follow Sanatana Dharma, interested in Vedic mathematics. Briefly he has given the profile, but so he has a vast knowledge of other topics also, as you all see in everyday lectures. So now let us request Gautham ji to start the webinar.
Namaskar and Dhanyavad, Colonel ji. Screen has come.
Come.
Yes, yes, it has come. Yeah.
Yeah. Now, this is just introductory course on Vedic mathematics, because if you have an idea, thereafter, whatever the other advanced topics you can think of, that sometimes you can see, read yourself, or even you can practice further and develop this subject. Now, I give a short introduction on how the mathematics started. Sorry, my voice, if the voice sometimes you do not listen properly, you please ask me to repeat. I'm suffering from some problem in the voice and some cough and so on. Now, counting start when something has to be kept track of, say sheep's number of sheep going there, put a dash on the ground. And then the most initial number system was only the dash. Thereafter, to count those dashes properly, they put like that, after each 5 of them, then there will be a horizontal line. So counting of 5 at a glance, it can be counted that way. Counting becomes easy. That way, number system gradually developed. Now, Babylonians have a good history of numbering systems. They had some symbols for 1, 10, 100, etc. But they didn't have the adequate number of symbols so that it can be compared, it can be established as a good, profound number system, so that all the different calculations that what we do today could have been done. Now, there is a Roman number system still under use for particular purpose. There are few symbols, alphabets in fact, and they denote particular values, and they are mostly additive. There is nothing that you see up today. This is there is a particular formula, like lower or higher value when to subtract and when to add it. So there is an example that if VI becomes 6, but IV is 4. Likewise, I have given the example. So Roman numbers are still used as ordinal number till date. No, cardinal and ordinal numbers. So cardinal number is a number that says how many of something are there. For example, 1, 2, 3, 4. Really count of that. And ordinal numbers are tells the position of something in the list. First, second, third, fourth, etc. Now, mathematical calculation can be done on cardinal numbers. So obviously, 3 mangoes are there and 5 mangoes are there, total becomes 8 mangoes. But there is nothing called, say, somebody's roll number is 3 and somebody's roll number is 5. We cannot add the roll numbers, has no meaning. So roll number, P and others, these are example of ordinal numbers. Although these things are used, same symbols are used. Now, the real mathematics of today started with the positional number system, which was developed in India first. So the positional or place value number system was known in India since Vedic times. But Aryabhatta in a known history in 400 AD, they have started using more profoundly, and then it became spread to Arabs in 6th century and was spread to Europe in 7th century. Now, since 8th century, all other number system has gone, and then only Indian these positional number systems were being started using. Of course, in that cardinal number, as I told, Roman the symbols are still going on. It's a different story. Now, and because the European gods got those numbers the system from Arabia. So it is called, they called it Arabic number system. Sometimes they call Indo-Arabic number system also. Now here, 9 symbols, 1 to 9 are used to denote numbers. And when some place has no value, the heavy dot was put as the circle, heavy dot or a circle was put in place under the placeholder. The placeholders are there, like unit, decimal, hundreds, and so on. And so if that this there is no value, means 1 to 9 values are there. It is the dot was put, so it becomes the discovery of zero, so-called discovery of zero, which is actually a corollary of the place value system. Why I put this point? Sometimes when people ask each other that what is the contribution of India in terms of number system, they told that is zero. It is not actually zero. Zero is just a corollary of that. Contribution of India was the place value system itself. And the number of symbols is equal to the base. There's about 10 is the base. So 1 to 9 plus that 0 will make it 10. And that gives this the most modern number system, and still whatever you are using, that it is that modern number system that we are using. Now, use of 0 as a part of calculation, that didn't come so easily. Gradually it got developed. So in 628 AD, Brahmagupta wrote a book called Brahmastupa Siddhanta and developed the rule for arithmetic involving zero and negative numbers. Any number subtracted from same number gives 0. 0 added or subtracted to any number results in that same number. Any number multiplied with or divided from 0 produces 0. 0 divided by something. But square and square root of 0 is 0. However, the issue of division by 0 was not correctly handled still. And in 830, there is a Gonita Sarasamhita by Mahavira. That too, that division by 0 was not handled. Gradually, and even 1100 it was not done. Even though when the concept of limit came, then that, and people tell that sometimes certain the elements of calculus were in fact developed in India, but that I didn't get exactly that any proof of any particular writing on that particular text. Now, concept of base in place value system. Any positional place value system will be associated with a base. In India, worldwide, the number system used the base 10, so that it is thought that 10 fingers prompted one to first take 10 as a base. Now, because this is 10, so it is called decimal system. Various powers of 10s are holding that particular place. Actually, there are place value or position. So you need 10, 100, 1000, etc. These are the different places, and with the values of values are you need 10, 100, 1000, etc. And the name of the place are power. These powers of 0, powers of 10, 0 power, 1 power, 2, 3, etc. For computer, the most natural number system is binary, because in the circuit, in any electronic circuit, whether the voltage or current is on or off, only 2 states are possible. So therefore, the binary system is the most common. If something is working, some voltage is there, we put it 0, it's off. And when voltage is, there is a voltage, say 5 volt, normally the circuit voltage comes. So it becomes voltage is on, that is 1. So with the this arrangement of 0 and 1, the whole binary system can be developed, and the multiple of that binary system, say group together as 3 gives octal with base 8, and if the binary is grouped into 4, this gives hexadecimal numbers with base 16, and the digits are 0 to 9 and alphabets, because more than 10 digits are not available as per decimal system is concerned, and the extra 6 digits in hexadecimal are taken from alphabets A, B, C, D, E, A, and their values are given as 10, 11, 12, up to F for 16, F for 15. That way, hexadecimal number will come to, at the end, I will come to this part. Concept of place value and face value. Now, what is placeholder? This place value system, the value associated with each placeholder. The place value is the digit that occupies that placeholder is the face value. A particular digit we write, say, for example, 756. So 7 into 100 plus 5 into 10 plus 6. But 7, 5, and 6 are face values. Whereas this 100, 10, and 1, these are place values. So we are basically multiplying this face value with the place value. Face value multiplied by place value, and we are adding that. And negative place value is also possible. There it is called fraction. Fractions that can be expressed as a decimal notation by this negative place values, where the powers of you see in integer we had how much? We had unit 10 to the power 0, 10 10 to the power 1, 100 10 to the power 2, etc. But here we are getting the first digit towards the right of the decimal point is 10 to the power minus 1, the next one is 10 to the power minus 2, and so on. So this is the negative place value. But in Vedic number system, negative face value is also possible. These are called vinculums, and specific cases vinculum makes calculation easier. We will see that in modern mathematics we do not use that much this vinculum. Now, the numerical symbols that are used worldwide, that is very interesting to see, because this 0 and 1 to 9, where these symbols we are giving, these are all English symbols. So various countries have their own, although they are using this place value system developed in India, but they have particular numbers. They had the different symbols of their own. This is fit with that their language, own language that is used. So there is a Unicode system by which these can be now typed easily, because all the languages of the world are codified in terms of Unicode system. That is a different story altogether. And there is some ASCII code for before Unicode. Only small things are handled by ASCII codes. So there is this English number systems have this code of 30 to 39 only. I mean decimal 48 to 59 and 30 to 39. Interestingly, numerical calculation can be done using other symbols in MS Excel sheet. Suppose in Bengali or Telugu number symbols, you can do add, you can do subtract, multiply, etc. This is possible. Number of Chinese and few countries do not use place value system. Chinese, there is a particular system they have used, and they do not use, since they do not use place value system, there this number symbol that we are found in the Chinese are cannot be accepted as number in Excel. These are not actually numbers, you put as just text. The symbol can be displayed in MS Word by writing hex code followed by typing Alt X immediately next to it. So you can try these things. That hex code you write and then just do Alt X, it will be that particular symbol will be there. So we'll start with this one, with Indian symbols in various states. So this is suppose Hindi 0. What is the code of that? 0966, 0966. So if you write 0966 and put a Alt X, so it will, this 0 will be displayed. Suppose in Telugu, suppose you are interested in Telugu, suppose you want to Telugu 5 you want to write, okay. How to write? 0C6B, and you write a alt text, you'll get that this particular symbol of Telugu. So these all are in different Indian languages. this in different Indian languages. These all are used. Actually, these are the values of all these columns. These are not the values. These are not the values. These are the fourth digit of the hex code. And this is the English. Why I wrote English here? This is the values that they are denoting this particular. This is the column of 8. 8 Bangla 8 is there. This is the Gujarati 8. This is the Odia 8, and this is Tamil 8, and so on. So this coding system, you can try this thing. Similarly, there are in other countries, there are also their own systems of numbers. English are there, obviously, that is used everywhere. Now, there are other countries, Arabic, these are the symbols. They are 6660. There is not uniform starting is there. So therefore, I have not written that way. This is the, so if you write 0660, that's 660, it will produce this one. 661, 662, 3, 4, up to 669. So these will be, and all text will produce these numbers. Similarly, Thai, E50. Okay. This is Thai, my number, all this is there. And this, as I told, using these symbols, all that, Indian numeric symbols or these international numeric symbols, one can do calculation. It is independent thing that if they want to do calculation, they can use their own symbols and do all kinds of calculation. There is no harm. Very peculiar. I don't know the reason why Ethiopia, they do not have a zero. How they manage without a zero, that is very surprising. This is about the different symbols. Now I come to what is Vedic mathematics. Vedic mathematics are, there are some intuitional use of 16 Vedic sutras and 32 sub-sutras. These are called corollaries. Later only 30 are used as sub-sutras, and these are the some are from Vedas and in tackling any mathematical problem. Vedic mathematics is collection of various alternative methods in solving any mathematical problem and develops better control on number system. So by doing Vedic mathematics, and as you told that any our shastras, studying of any shastras always will associate mental processes like meditation and so on. So if once through meditation, when one gets better control of one's mind, and then they study the Vedic mathematics, then this control of mind give rise to new insight about number system. That is the only. I didn't write that meditation part. So this both comes together. In any Indian study, always or self-development will always be associated with. What in Western system, these things are never emphasized. That you have to do your self-development also in terms of yoga, meditation, and so on. So Vedic mathematics should be taken in that spirit, and they will find when your mind gets more flexible and more concentrated, you will find that these various alternative methods will give you a better control of the whole number system. It aims at developing mathematical intuition in choosing the best method in case-to-case basis, rather than mechanically adhering to only one or few methods. Since childhood, we have learned one method probably of each of these addition, subtraction, division, multiplication. So when you learn mathematics, you learn additional things. Not that whatever we have learned has to be thrown away. No, I'm not telling, never tell that. That is one of the method. There can be multiple methods of equal or at case-to-case basis, more efficient, less efficient, everything. A particular case, a particular method can be most efficient, other maybe less efficient, so on and so on. Practice of Vedic mathematics can be a method of mental development in parallel to solving the mathematics at hand. So this gives a sort of, as I told, coupled with meditation. So this gives a better intuitive development of your control of mathematics, mentally developed in the mathematical side. So this, the most inspiring book on this is Vedic Mathematics by Bharati Krishna Tirthaji. I will give the link to you, and if you can search in Amazon or this thing, link will be given. It is 220 rupees or something like that. I suggest all of you to kindly purchase this book, and this will be an asset throughout this thing. And this actually, and many a time, many people, Vedic scholars even, they some of them put a doubt that whether this Vedic mathematics that they have put Bharati Krishna ji, everything is there in Veda really or not. But that logic is also given by him in this book, that why he called Vedic mathematics, that mostly it is intuitive mathematics, the Vedic way of thinking, as I told you, with meditation also, and with parallel to self-development and so on. So these are the 16 sutras, main sutras. Ekadhikana purveno, nikhilang navatas charamang dasataha, and urdhoti jagabham, and parivarta jojaya, etc. These are different meanings are there. And these are the 16 sutras, and these are the 13 sub-sutras. So we study of them. The meaning of that Sanskrit words are there, and the meaning is there in English. Ekadhikana purva means one more than the previous. Nikhilam navatas charamang dasata. All from 9 and ultimate from 10. Urdhati jagabham. With upper, direct upper, and with slant. And paravarta jojet. Transpose and apply. At least one reaction I want to get, whether I was audible and everything is going on nicely. Any reaction from the?
Yeah, it is going on nicely, very clear and loud. No
Okay.
problem at all.
So these are the meaning of that. Fast forward one. Then Sunnam Sammo Samuchate. A common factor is the same, which is 0. Onuruppe Sunnamannat. If one is in ratio, the other one is 0. Then Sankalana Vyakalanabhyam, by addition and by subtraction. Purano Opuranabhyam, by completion and non-completion. Chalana Kalanabhyam, sequential motion differentiation. This Kalan word actually used for differentiation. Javadinam, the deficiency. Vesti Samasti, whole as one and one as whole. Vesti means a collection, and Samasti. Vesti is one and Samasti is more than this collection of that thing. Sesanankena Charamena, remainder by the last digit. So there are so many other, the other 16 also there. Gunita and Gunaka and multiplier. Gunak means multiplier, and Gunita, the whole products. So also. Earlier you had Ekadhikana Purvena, and now it is Ekonunneno Purvena, means that one less than the previous. About the sub-sutras, Unurupena proportionality, there are also meanings of the sub-sutras. I will share you another file where these are also, there. So it will all studying in all different aspects, it will help actually. Now, scope of mathematics: arithmetic computation, multiplication, division, recurring decimals, divisibility. With divisibility means without actual division, one can test whether it is something is divisible by a number or not. Highest common factor, equation, factorization and differentiation, integration. I didn't write one thing, I can now add it. These are there. Arithmetical computation. The rules of addition, subtraction, multiplication, division, which are conventionally taught in school, all have some or other algebraic background. Thus, once the inherent algebra is changed, the procedure or method gets changed automatically. Thing is that when we learn something in some formula we use, not that we will the algebra we apply, but we do not go back to the conventional method of handling that algebra. The procedure itself gets changed. That is this has to be kept in mind. You will find that it is a whole procedure you are taking in a different turn. We'll see in course of time. In Vedic mathematics, negative phase value is also used. That's especially for number more than 5. And okay. As I told, negative phase value is also used. Now, how to do that, handle that? What is the procedure of this negative phase value? We know that some number is more than 5. We are a little less than 5. If we compare this less than 5 or more than 5, we find that less than 5 are more easy to compute than the more than 5. So, therefore, whenever we find more than 5, we can express as something less than 5 using vinculum. The 48 can be used as 5 and -2 as a unit digit. This is an we cannot write -2, then it becomes 5 -2, looks different. So 2 of the bar above means there is a negative phase value. On the place value of unit, there is a negative phase value. So it is 50 -2, it becomes 48. Okay, is it clear? I will come to further. A number with bar above, is called vinculum notation. So it is used in Vedic mathematics for negative phase value. Now there is something else there you can write those up. There's a character here actually, but it didn't work all the time. So I use graphically. Actually, there's very problematic to report to represent that. Unfortunately, the Unicode system didn't have this vinculum fitted numbers as codes. Otherwise it will be difficult, easy. Now 6 is 10 - 4. So vinculum notation of 6 can be used as a 1 and 4 vinculum. 97, 100 - 3. So it is 1 0 and then 3 vinculum. So in similarly 143, 143, 142857, 289, 300 minus 11. So 3 and this 1 line is there. This way. Now, what is the particular formula by which you are doing that? Nikhilam, all are carrying that paper and pencil.
Yeah,
You
yeah,
have told.
yeah. We are carrying pen, paper and pencil. Yeah, go ahead.
And the formula is Nikhilam Navatas Sarvang Dasata. Now, can I get some audience reaction regarding this particular vinculam, learning the vinculam?
Yeah, participants are requested
Participants reaction.
yeah, please speak out if you have understood or if you have said something.
Because here the understanding is very much important. Otherwise, we cannot enjoy further. Cannot.
You can unmute and speak, no problem.
Yes, I can understand
Yeah.
the number with the bar on it needs to be subtracted from the other one, the bigger number.
See here, 1,43,000, 1,42,857. So this is actually 1,43,000 minus 143. If you do that, so this is vinculum means this is negative. So 143,000 minus 143 becomes 142857. But these kind of things are not in normal subtraction. But in Vedic mathematics, we use this formula. It does automatically that Nikhilam Navatas and Charamang Dasata. So all from, suppose there is a whole thing is vinculam is there. Nikhilam Navata. All others are from 9. This 1, see, 9 minus 1 is 8. Okay. 9 minus 4 is 5. But Charamang Dasata means end is, in fact, end means vinculam end, one can say. There can be multiple vinculam in a sequence. In a particular vinculam is ending, so that becomes Charamang Dasata. But before that one, it will be equal Nunnana Purvana again. That vinculam, when we begin up the last one, which is non-vinculam, has to be reduced by 1 also, you see. Here also you will see 13244 in vinculam. First, this gets equal, this gets reduced by 1, this 2, and then this others are subtracted from 9. So 9 minus 1 is 8, 9 minus 3 is 6, 9 minus 2 is 7, 9 minus 4 is 5, but last one is from 10. 10 minus 4 is 6. So this is called Nikhilam Navata Charamang Dasata, all from 9, last from 10, and then the beginning is Eko Nunnana Purvana. Means that the Purvana means Purvana of vinculam, whole vinculam sequence. So the Eko Nunnana, 3 minus, it becomes 1 less than the previous. So this is about vinculam. And it will be the other way around when want to do vinculam. As was told earlier, vinculam means negative face value, accepting the sign. It works exactly the same way as positive face value. When we are getting, you will get good practice. You will be very easily you can handle these positive and negative numbers, like we do in positive and negative numbers. Here you are using the different notation called vinculam. Vinculam is applied to reduce effort of calculation. Experts and intelligent use of vinculam will require table of up to 5 cross 5 only. In any workout of addition, multiplication, division. Here example of one that using Nikhil's Sutra Vinkulam, how all large addition can be done. Large means I only use 4 lines. It can be more than that. So suppose these things are given here. These numbers are given. 3, 9, 6, 7, 8. There will be a lot of other issues. 8 plus 9 plus 7 plus 8. You do this thing and carry this thing. You know, all conventional. It can be 10 lines as well. It will be very, which large numbers will be very big. But whereas with vinculums, especially I chose this particular example where the vinculum you get small. It can be a mixed also. Just to show you idea, simplified example is given, taken like that. So 3, 9, 6, 7, it becomes 4, and the rest 4 are in vinculum, which is less than 5. If where the digits are or the addends are less than or equal to 5, it can be converted. That depends on exactly when the less or more of 5, that also it is a choice is yours. On 5, what to do about 5? Whether to convert this 5 to vincula or not. So that involves choice. But others, obviously, it's more than 5.
A second example, 2, 7, 6, 8, 9 cut 3 to 3, 1, 1. If you apply the same logic, then the answer should not be what it is shown. 3 to 3, 1 should not be there.
Which one?
The second one.
See, this is 9 minus 7 is 2. 9 minus.
The first digit 2 minus 1 should be 1. It's 2 plus 1 over there. Starting with 3.
Oh, no. What I'm doing, yes, when I am converting this non-vinculum to vinculum, this has to be added. Otherwise, how it can be subtracted? There, see, in that example, I had given how to, from vinculum, I have to give non-vinculum. There, we are reducing. But it is the other way around. No? If it is like this, you have to come from this side to this side. So this has to be added. Okay. So this is actually, these are, I am telling like, but actually background, you see the background, what is happening. I'm just coming to this. So this, I converted to vinculum. 1, 8, 5, 6, 7, this comes 2, 1, 4, 3, 3, and 4. See, this is actually this. Our conventional mathematics is this actually. 40,000 minus.
Excuse me, sir. Sir, just please tell me one example with clear steps. Then we follow other numbers and pick up. Are you understand me?
Clear step means?
Sir, 3, for example, 3, 7, 6, 7, 8. What is the procedure to obtain the answer? Please tell me. Then we follow other numbers.
See, when a number like this, where the more numbers are there, this actually I started with this one now. See, 48.
40.
Okay, 48, you are writing, see, you are increasing it. 5.
Yes. 4 plus 1, 5.
First you are increasing it.
Yes.
But to
then
compensate
9
that, increasing means it becomes 50. Then to compensate it, we put a -2 in the face value. So it becomes 50 minus 2. So obviously from non-conventional number to vinculum, when you are using, we have to increase that first digit, the last of their non-vinculum number. Okay. And if it is only 1 digit, so it is obviously it will be more subtracted from 10. 10 minus 8 is 2. Okay.
Sir, why only 2? Why not it can be something else in your example? Why only 2? Because 4 you have increased to 5. Okay. And 8 you have reduced by 2. Why? Am I audible?
Yeah.
It is not.
No, there should
it
be
is-
some, I think, I don't know, because you are well knowledgeable and all. If 48 can be represented as 5 bar 2, why bar 2? Why can't it be bar 1 or bar 7?
Oh. Bar 7. Bar 7 are not required. Bar also can be only up to 5.
Okay, then
So-
it can be bar 4, na? What is
okay,
the
okay.
logic we are trying to understand, sir? Please, miss.
Okay. No problem. Yes, that is the student like behavior. No, it's good.
Yeah,
Welcome. You called it is 5 bar 4. Huh?
yeah, yeah.
It can be there. 5 bar 4 is number. But how
Ah,
much it is? How much it will be? It actually
46.
the face value and place value. 5
46.
into 46. 5 into A plus minus 4 into 1, isn't it? So this is unit. It is when it is a 10. There is 100, something like that. No, this is the vinculum. You are using here. Negative also is allowed. So 5 into 10 plus minus 2. This is 50. 50 minus 4, which is 46. But the idea is we don't have to do always like this. So by using the Vedic formula, it will become very easy actually. Okay. So as soon as you get that, one doesn't do so much thing. We see heard that when non-vinculum is converted into vinculum, it becomes 4, reduced by eco nunnana purvena. And this is Nikilam now the Charamang Dasata is already Charam. So it is 10 minus 4 is 6. That way you do. Okay. I give you again another example.
Sir, can you please show an example for 3-digit, because 2-digit kind of understood. So the 3-digit.
What is that?
273.
27?
Three.
No, not
276.
276, sir.
This kind of expertise I require. This is intuitive also. This kind of expertise should be there. So this basically is 300. 3 in this is ekak unit. This is tens.
Okay, got
this
it.
is 100.
Got it. Okay.
So the 300 is there. 300 minus you can say. But the 9 7.
Gautam ji, your audio is slightly wavy.
Oh.
Yeah.
Now it is okay?
Yeah, now it's okay.
Now actually probably I have to change the network connection. If problem persists, I will change the network connection.
Right now it is okay. Go ahead.
Sir,
So
in the
I
three, sorry,
go
sir.
back to my
Yeah, in that 3-digit number only. So, for example, if go back to your example, sir, I think 324. I mean 324 bar 24. So
bar.
Can we have a 1 bar? Let's say 332 bar is only for 4. No, what is the meaning of that?
Meaning of that?
What is the meaning of that? And 3, 2, I mean bar for 2 and 4.
See, this means actually 320. It is
And
320 minus 4. This means.
okay. So again, can we also use this in the middle of the number, meaning 3
Yeah.
bar 2 and 4?
Yeah. So
Like
this
that.
becomes this becomes 2, 8.
Oh, okay. So that is
And
what is
this
a
becomes
placeholder, and you know that you.
this
Sir,
becomes
display is
3.
not coming, sir.
Huh?
Sir, display is not coming.
This display is very much clear there. So try to adjust your mobile or what's laptop.
Okay, sir. Okay, sir.
No, my presentation is coming properly.
Yes. It's very clear.
That's very clear.
Sir, can you explain once again that 3 to 4? 3 to vinculum and 4. Elaborately.
So actually, see, we are since childhood we are practiced to see only positive numbers in as a face value. But when the face value becomes negative, how it will behave? That in the next, what thing I can do? I just finish that particular this thing, and in that process we will get more questions. Okay, will it be all right? Let me finish this example because
Right.
time is also already about 7:30.
Right. Go ahead, sir.
It will be with practice. It will be easy. See, here it is. Now you are concentrated on this particular example. 39678. So we made it 4 because in background 40,000 minus 0322. So it see 40,322 is subtracted from 40,000. This gives rise to 39678. That is what the background is going on. So we write this vinculums, we write using our Ekadiko Purveno, and then subtract from 9, this one, subtract from 9, subtract from 10. That way we do everything. But background is this thing is going on. Now, idea is that we add this thing. Adding these things becomes very easy compared to this. Add 8 plus 9 plus 7 instead of 8 plus 9 plus 7 plus 8. We add only 2 plus 1 plus 3 plus 2. It becomes 6, 8. We write all the negative. So 2 plus 1 plus 3 plus 0, 6.
Gautam ji, what's happening is that your cursor is too small. Nobody is able to see it. And increase the size of the cursor or change the color. Now it is okay. There is a color, add color.
Yeah. See, 2 plus 1 plus 3 plus 3. Earlier you are supposed to do 8 plus 9 plus 7 plus 8. Now we are doing 2 plus 1 plus 3 plus 2 is 8. 2 plus 1 plus 3 plus 3 is 6. 3 plus 3 plus 4 plus 4 is, this is 14, but 1 is carry, and 2 plus 1 plus 2, and then becomes carry becomes 6. 4 plus 3 plus 2 plus 5 is 14. In the background, this is happening. All these things I put this way. I separate the positive and negative parts. So express it because we are practiced with only positive numbers as face value. So in background it is happening like this, and we add all these things negative or all the positive, and finally subtract and get these numbers. It's clear? In Vincula we are doing it automatically. In background it is happening. Okay. You just practice it. Here another example I put, and a different kind of example. Here is quite mixed. Numbers to add are 39274 plus 53749, 28362, 43826. Here we converted it like this, or mixed positive and negative. Here we find 4 minus 1 plus 2 minus 4. It becomes 1. Minus 3 plus 5 minus 4 plus 3 becomes 1. 3 minus 3 plus 4 minus 2 becomes 2. Minus 1 plus 4 minus 2 plus 4 becomes 5. And this 4 plus 5 plus 3 plus 4 is 16. So it is like, basically it is expression is like this. 41334 actually is 40. If I write all positive also, positives only, what we understand normally in positive. 40304 minus 0301 basically. So 40,301 minus 301 is this 3927, isn't it? So now how it is happening? Basically as if we are exchanging the role. That way it is designed, and so it will be it gets reduced. Okay. And when we it will take more time to understand properly. But this is the you know that vinculum by which the vinculum is there.
Gautamji, I think the bottom addition numbers, there's a change 165511. Is it okay? I mean, because all others are 165211, 165211, and when it comes to the left.
I see. Oh.
Yeah.
Yeah, right. Yes,
I mean,
yes. I must be a mistake. Yes.
It's only a typographical mistake, but students may think other way.
Yeah. See, 2 is there. How can it be 5? I correct it. I'll correct it. Thank you for reminding me. See, you see from the top, just a mistake. That's all.
Thank you. Go ahead, sir.
So is it clear?
Sir, I understood the conversion part here, but when you add the vinculums, can you explain once again, like 4 plus 1 plus 2 plus 4 in the unit place?
No. 4 plus minus 1 plus 2 minus 4. This gives 1.
Okay, right.
Vinculum is actually negative.
4 minus 1, 3 plus 2, 5 minus 4 is 1. Correct. Okay.
That way.
Thank you.
Or you can directly this 4 and minus 4 gets cancelled. 2 minus 1 is 1. 3 and minus 3 gets cancelled. Minus 3 and 3 gets cancelled. 5 minus 4 is 1. This 3 and minus 3 gets cancelled. 4 minus 2 is 2. This also you can do. No?
3.
4 plus 4.
Yes, sir. Thank you.
So this is the otherwise you are handling with big numbers. Instead of that, you are using numbers. It will be more easier in it will be easier even in multiplication kind of things. There will be practice the better multiplication can be done with using vinculums. Now, why I give this particular page is that sometimes some people in the name of Vedic mathematics, they give so responsible tricks like this. This is a good trick actually. That you do 15 square, you do 1 into 2, 1 and with the next of that 1 and 2, and then 5, 25. 25 square, 2 into 3, 6, and then 25. So people learned these tricks and were told that these are all about Vedic mathematics. But this is okay, but these are not the all of Vedic mathematics. Vedic mathematics is more vast subject. It gives, as I told, it gives more insight on the numbers. It is not just shortcut method or doing some mathematical magic on that. These are mathematical tricks on like that. So deeper understanding, more rigorous thing is there with Vedic mathematics. This point of view has to be set in mind. So I just start this particular thing. If I have time, I can start this thing. Now, multiplication near a base. So sometimes you use vinculum, sometimes you do not use vinculum. But the meaning of vinculum is already gets reflected. The procedure of vinculum, and so on, automatically gets implemented. So this kind of multiplication, 97 into 93, 987 into 900, this kind of things, which are near a base. Base is equated to or something. A base is defined as the nearest power of 10, which must be the same as the multiplicants. Same for all multipliers actually. One is near 100, another is near 1000. This will be a different procedure actually. We are not discussing presently here. Maybe it is the next course will be in the next level. 97 minus this 97 and 93 are multiplying. So it is 100 is the base, 100 minus 0.3. Some sound is coming. One can, whenever want to ask something, can switch on the this audio, microphone.
Yeah, I'll do it. I'll do it. Don't worry. Go ahead.
97, this is actually 100 minus 3, right? Minus 3 here. Minus 0.3. Same number of digits. So 93, which is 100 minus 7. So 100, but we write 0.7. This is important because you have to keep the same number of digits. Then the procedure is that 97 minus 7, 97 minus 0.7 becomes 90, or 93 minus 0.3 becomes same, 90. And this 0.3 minus 0.3 and minus 0.7 becomes positive 21. So this becomes, answer becomes 9021. We give a larger example. This 100, 10,000 and 10, also 10,000. So 997, we write here minus 003. 993 minus 007. Here we multiply these 3 into 7, 21. But this one, 997 minus 7 is 990. 993, 003 becomes 091. Here again we do, specifically I am taking that example because we'll see that how they see that increasing the more nines about the multiplication result in addition of same number of 9 in the first part and the same number of zeros in the second part. This is the only thing. It doesn't matter how many 9s are there. If the same last numbers are there, you can see that easily that numbers are, or 9 is increasing here and 0 is increasing here. So this so easily you can do all this multiplication. Here you gave another number, 9876. So it is 10,000 minus how much? 0, 1, 2, 4. Here also that 9 minus 9 is 0. 9 minus 8 is 1. 9 minus 7 is 2, and 10 minus 6 is 4. Nikhilam Navatas Charamang Dasata. This is the formula to write this part. 9987 becomes 0, 0. 99 gives 0, 0. 8 becomes 9 minus 8 is 1, and 10 minus 7 is 3. This is just because there is nothing to reduce or something more than that. Already it's 10,000 you are doing, so you are not writing anything, means that you are reducing this. Reducing part is there. It's only Nikhilam Navatas Saramakas you have to think of it. Not the other one, not that. And there you write 9876 minus 0013 becomes 9863. And this 123 and 30 becomes 1613. For that also, one can do another thing. That will be both are of different different length. It will be different. Bases will be set different actually.
Yeah, the bases are different, so it will be a bit complicated.
So here we did see as I told, conventional. We don't have to reject the conventional one. You just do conventional the 6 and 1 6 1 2, and then you can. What is the algebraic expression of that? The 9 minus n minus 1 n minus a into n minus b, and n into n minus b plus ab. This is the ab part, and this is the n into n minus a minus b, because this is, see, this is already n minus a. See, if this is a and this is b, this is already n minus a, this is n minus b. So when you are cross subtracting, this n minus a minus b. So this becomes n minus a minus b. And you are shifting so many digits. Means that you are multiplying with this n. This multiplication by n is performed by shifting it so many digits. And this is n minus a minus b, and this is ab part. Is that clear? How this formula is relevant here? Anyone?
See, participants are supposed to react.
Sir, could you explain once again, sir? If n is 10,000, here in this case of 9876,
Yes.
A will be 124 and B will be 13. So,
This is already n minus a, 9876 is n minus a, and 9987 is n minus b.
okay.
Clear? Okay.
Yeah.
So 9863 is n minus a minus b. Because this was already n minus a. This was already n minus a, and we are again subtracting this b. So this becomes n minus a minus b. Or this was n minus b, we are subtracting this a, so it becomes n minus a minus b.
Okay, sir.
Okay.
So we have to either subtract 9876 with 13 or 9987 with 124. Either ways.
Cross subtraction.
Okay.
So this
Okay,
becomes
sir.
n minus 2 to arrive at n minus a minus b. And then we are doing a plus a into b. Part.
Yeah.
And this very process of shifting so many digits are equivalent to multiplying by n. Okay.
Okay, sir.
Shifting 4 digits towards left means multiply by 10,000.
10,000.
So this becomes, side by side it is written, but its total number becomes the answer. So this actually, in the background, this is happening. Clear?
Sir, but that
Yes.
10,000 multiplication,
Found
sir,
it interesting?
sir, quick question.
Huh.
That multiplication with 10,000 is only for the term n minus a minus b, right?
Yeah, exactly.
But it is not for ab.
No. See, if you algebraically these two you factor,
Yes,
you,
sir.
you write in this X form.
Yeah.
Okay. This is n square minus
Correct. I understand that, sir.
plus
But
AB.
only
It
thing
is
that I was
outside.
not able to connect was the 1612 that we are getting on top.
Yeah.
I was probably unable to understand how that gets, even that also gets shifted. Oh, that shifting is only for 9863 then. Okay, got it, sir.
Exactly.
Yes, sir. Got it. Okay, thanks.
This is the AB part. So similar to that, multiplying near a base but above. So what are the patterns here? 107 into 103, 1017 into base, like this one. What is above this, above a particular base? It is actually same as previous one. Only thing is that you write with plus, and you do the similar thing. You do it plus here, so it becomes 110, and this becomes 21. I put the same kind of example, except minus, it becomes plus actually. So here also get those kind of things. 1007 into 1003. It is more than 1000, so it is 007 plus 003. It is 21. This 1007 plus this 3 is 1000. This is 10,000. 10. It becomes 10128 here. This is more thing. Here it is also. Here you see that when the number length, same kind of digits and number increases, there will be one more zero added. See, one more zero added in the first part, one more zero added in the second part also. Earlier it was 9, the first part, but it is now always it is 0 added. Same, it is algebra expression. N plus A plus into N plus B is N into N plus A plus B. This was already, this is A and this is B. This is already N plus 1, N plus A. This is already N plus B. When we are adding the cross addition you are doing, we are making it N plus A plus B, this part. And then we are adding it and shifting it to so many digits means multiplying with N. And then we are adding this AB. So this is also, here the cross addition is this, and AB is the multiplication in the second part. Okay. Now, challenge comes when it becomes mixed. There the more use of vinculum comes actually. Near the base, but this is the one is positive, another is negative. How to handle that? So the example is given here. 93 into 107. So it is minus 07 and plus 07. So it becomes 93 plus 7 is 100, or 107 minus 7 becomes 100. And 7 into 7 becomes 49 in vinculum, negative 49 actually. So how to do it? So result becomes, this is the final result, 10049 above. How to handle that? Equal becomes 99, and 4 subtracted from 9 becomes 5, and 9 subtracted from 10 becomes 1. This 9951 is the answer. Clear? For example, 1013 plus 13 and 993 minus 007 becomes 91 negative, and 1013 plus minus 7 is 6, or same thing, 993 plus 13 becomes 1006. Here also, this is 10,003 A is this, B is this, so this one. So it becomes 3 into 7 is 21, but 1 is plus, 1 is minus, it becomes the whole thing becomes minus. So 1003 minus 7 becomes 9996, or 9993 minus 3 becomes, sorry, 9993 plus 3 becomes 9996. And then when you clear the vinculum, it becomes 1005909. This is subtracted from 9, subtracted from 9, subtracted from 10. And this becomes reduced to 5. So 9995 and 9979 it becomes. So expression is this: n plus a into n minus b, n into n plus a minus b minus ab. This is the thing.
Sir, can I have ask a quick question in the previous slide?
Yeah.
Sir, when we're having plus 013 and minus 007, we are getting the answer as 91, which is negative. That is why you're probably putting the vinculum on top.
Yeah.
So why should there be 3 digits that we have to take? Would it not be vinculum 91? And why should we take it as 091 vinculum? Because that will have a change in the result, right?
No, no, no. No, it is 0, whether you put vinculum on top of 0 or not doesn't matter. Because there is no difference between plus 0 and minus 0, isn't it?
Yeah, that is true, sir. But when we are trying to combine with 1006, because 1006 vinculum 91 is different from 1006 vinculum 091.
Oh no, 091 you had to be there because 091 had to be there because this number of digits have to be put same, no? This, as I told, it is above base.
Yes, sir. It is only 13 above base. So why should we write 013? Why not 1013 plus 13?
Yeah. No. Because actually that is the same number of digits you have to put. Same number of digits. From studying itself, we did like that, no? Here you are doing 2 digits. When this is 3 digits, we put 3 digits. Okay. It depends on the base. How many zeros are there in the base?
Oh, okay. So whatever the
How many
base
zeros are there
has
in the base?
zeros, same we have to put. Okay.
Otherwise, it will be calculation will be wrong.
Okay, sir. Got it.
Number of zeros in the base, that has to be taken as the number of total digits in that.
Yes, sir.
Everywhere. The above or below or mixed, whatever it is.
Yeah.
Same number of zeros has to be.
So just for the purpose of calculation, I mean, it doesn't make sense at all. But let us say if a number is just given as 9. So can we just add, I mean, normally we will take it as base 10, right? When it is 9. So instead, can we take 100 as the base and still add 1 more 0 and make it 91 and then still try it? Will it work? What I'm saying is, sir, in the case of base 1000, we are subtracting 13 or adding 13 to it now. So it is becoming 1013.
If you choose a different base, you have to calculation will be changed.
Okay.
It's not that it cannot be done, but yes, just
it become more complex maybe. I'll try it out myself and check it.
So this is called sub-base concept. I want to come. You asked the question and I want to come to that point. Multiplication near sub-base.
Yeah.
So always you may not get a convenient near base.
Close to 1000. Yeah.
So it is considered 483 into 497. What to do? So here
500.
Base is 1000, but sub-base is 500. Alternatively, you can put as base as, this is your choice, 100 and sub-base as 500. Procedure should be different, but like this. Base 1000, sub-base 500. In both cases, sub-base 500. So 483 is how much is from short from 500? 17.
18.
017.
17.
It is again the same digit should be as number of zeros in the base, actual base. 497 is 003. Here, this part we do as it is. 17 into 3, 51 it continues. But since it is sub base, how much the sub base is to that base? It is a it is actually sorry, base is twice. I'm sorry, I'm telling you. This sub base is half of sub base is half of base. So you divide by 2. Sub base is half of base. So divide by 2 and then it becomes 240. This becomes answer. On the other hand, if I choose base 100 and sub base 500, 483, number of zeros in the base is only 2. So only 2, right? 17. Right. No 0, 0, not 0, 17. It's 17. And this is 0. Again, the same procedure we do. 483 thing and becomes 480.
Yes, sir. Got it.
This is 51. But you multiply by 5.
By
so
5.
This 0
because it is
got
base
lost
100.
here.
100 into 5.
You got the 0 that we lost here. 0 we get by multiplication by 5.
Yes,
Okay.
sir.
Isn't it?
Sir, we can take any number as base then. I can take 250 also as a base.
Yeah. See, here as you're telling.
Oh, okay.
You are thinking one line advance. See, you are thinking advance because you are concentrating on this thing. Consider 235 and into 247. Base 1000, but sub base is 1/4 of that, 250. So 235 is 15 less than 250. So 015. 247, 001, 003. So it becomes 045 and then divide by 4. So we 5 is 045. Consider 18 into 45. Base 100, sub base is 50. 18 is minus 32 and 45 is minus 0.5. Here actually, sometimes a lot of tricks are there, sometimes carrier there, all these things. See here, it is a little complicated. So when you multiply 32 by into 0.5, it becomes 160. One I put in there as a carry. This is, it will not come in main this thing, it will be carry. And this 13 when divided by 2, it becomes 6.5. 6.5. So basically this is the hundreds digit. So 600 and this half in the 100 digits becomes 50. This 50 added to 160 becomes 210. It becomes 810 becomes the answer. Because a little practice sometimes, this kind of a little complication it looks like. Should I repeat this part?
I think today the time is over, 8 o'clock.
Yeah. Any question? This I just, should I repeat this part and then leave?
Yes, sir. That would be helpful.
Yeah, go ahead.
18 is, see here, base was
150
100 and sub
taking
base was
minus
50.
32.
18 is 32 less than 50. And 45 is only 5 less than, you would have put in 0.5, less than 50. So when 18 minus 5 or 45 minus 32 becomes 13. And 32 into 5 becomes 160. Because there are only 2 digits, we write 60 in the bold and then 1 we put as a carry. Had to be used otherwise, but this is not the 13 actually, because we have to divide it by 2. Becomes 6.5. So 6.5 in the hundredth digit.
Yeah.
In the hundredth digit, 6.5 in the 100 digits. What does it mean?
650.
If 6 in a If 6 in 100 digits, we write 600. If 7 in 100 digits, we
700.
write 700. But 6.5 in 100 digits becomes 650.
Correct.
Half of that. So this becomes 650. And plus this 160 becomes
810.
210. And this 2 added to 6 becomes 8. And this 10 becomes 10. So 810 becomes the answer. Now here, what is the algebraic explanation? Now this is the sub-base relation, the factor of the sub-base. Either it is multiplied by the sub-base is multiplication or a fraction of that. Whatever it is might be more than 1 or less than 1. M into n minus a, m into n minus b is mn. Mn minus a minus b plus ab. Basically, this is already mn. So mn minus, see, I'll show here. Mn minus a minus b, this part is already performed here. But n you are performed by shifting it these many digits. But this particular is performed by this again multiplied by or dividing by some number. Either multiply or divide. Here it is divided by m was 1/4. In this case, m was 1/4. In this case, m was half. In this case, m was 5. Well, the second part. Yeah. This was half. Okay. And then a minus b. Just you see that it will be clear. Okay. So tomorrow we'll start with another chapter. By today it is the end of the session. Thank you. Namaskar.
Yeah. Before Babu Garu starts, a lot of people have confusions, etc. Request is to go through the book, which has already been shared in the WhatsApp. Try to practice and then slowly do it. Don't say confused, because it is confusing if you don't follow. Please, that's all. Thank you, God.
Okay.
The PPT or shared, no? Somebody asked in the chat box whether the PPT is shared.
It's already shared. It's already shared.
I'm very much confused. You understand the logic of clubbing normal mathematics and Vedic. No, actually, the algebra, as I told, the background algebras are different. That's all. And each, whatever conventional mathematics we do, there is also a algebraic background is there. So here we are changing the algebra as a result. We are changing the procedure. Not that we are not using the same procedure with changed algebra. We are changing the procedure itself. That is the idea of Vedic mathematics, as I told. You have become totally flexible about the procedure also. We do not stick to that our procedure. Now we know only one procedure of multiplication, division, etc., and use some algebra. Not that. Changed algebra is giving rise to change the procedure. That is Vedic mathematics. So the conventional, what you are telling, this is one of the procedures. This is not something else. That is also not to be rejected. That is also one of them. One of the procedures. Vedic mathematics is giving you more than one procedure, more than that procedure. Clear?
Yes, sir. Sir, I had a quick question. One more. When we are expressing a number in vinculum notation, it means the same number can be expressed in multiple ways, right? So one example I typed in the chat box. So if the number is 385, it can be expressed as 4 vinculum 15, 1 5. 4 and vinculum of 1,5. It can also be expressed as 4 vinculum to 5. Would this be correct, sir?
Yeah.
So the same number can be expressed as 2 times.
Yeah.
4 vinculum 1,5 or 4 2 vinculum 5.
Yes. This is good. Yes, that means you are thinking. So that depends on your application, as I told.
Yeah.
The
Got
number
it.
5 we have choice.
Correct.
Actually, using vincula, we have the way that nothing should be seen more than 5.
More than 5, yes.
Had it been 486, 386.
Correct.
So then
5 vinculum 14.
So
Yeah.
here you cannot write 6 here. 4, 2
Correct.
and 6. It look
That is correct.
6 is not good. So that
Correct.
Yes.
Sir, my understanding is we are
yeah.
only reducing it. My understanding is we are only reducing it so that it becomes easier for calculation.
Exactly.
But the same can be extended even if I make it as vinculum 6. I mean, we can do it if we know the calculation of 6. We can still do it. It is just a matter of reducing it to a number easier for you. Yeah.
So, but there is no need of writing something is already somewhere 32.
Correct.
It is already,
no need to reduce to vinculum. Yes.
Don't have to do it. It's 2
Correct.
and vinculum 8.
Yes. Got it, sir.
Not required.
Thank you.
Okay. Nice. So see you tomorrow. Then there are a lot many questions are there. Some questions can be asked. In the meantime, you ask and you carry the paper and pencil. You practice this also. Okay.
Yes, sir.
So,
Thank you.
In the chat box, there is more questions. Okay. The college sir may every day may forward me the chat box also so that I get prepared also with the questions.
Sure.
Anything we can be cleared for the next day.
Sir, excuse me, sir. Sir, homework ka కొన్ని మాకు ప్రాబ్లమ్స్ ఇస్తే బాగుంటుందేమో సార్ రెగ్యులర్ గా రోజును homework గాను కొన్ని మీరు ఇస్తే ఇంటికి బాగుంటుందేమో మేము ప్రాక్టీస్ చేసుకోవడానికి.
You have to talk in English.
Sir, please give us homework problems, sir.
Oh, homework problem.
Tomorrow you can give a homework and have at the last you just post few questions so that it will be homework. Tomorrow it will be done. Yeah.
Okay.
So you can take homework like this for 2, 4, 8, 5, 8 plus.
You have your own numbers and try.
Own numbers. You put your own numbers.
Okay, sir.
And give these numbers like this, say 924 multiplied by 900, say 75. This kind of thing. Or maybe slightly made more complicated. No, doesn't as you told. It doesn't matter. The same effort is done for the both of these. Whether it is put 19, 29 or 39 doesn't matter. As we already learned. So this way you can design your own questions and then see how much easily you are being able to do. Okay. One thing can be done. Yes. This I didn't cover, so you can do this. You can write. I did only for 400. See 524.
Gautamji, sorry to interrupt. Gautamji, sorry to interrupt. A lot of people are on the job, so they'll have to leave.
Oh yeah. So this you can do 524 into 476. Let us see. One is above a subbase, another is below a subbase. Okay. Thank you. Namaskar.
Thank you.
Okay. So all of you have to understand today's mathematics, today's lesson, and come tomorrow and use that PPT which is given to you to understand. Once you sit down and put your brain, is not difficult. Okay. So now let us do a Prarthana. Chant Prarthana by Satyaji. Can you take out the presentation?
Yeah.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधना सधना सन्तु जीवन्तु शरदां शतम् सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जना सुखिनो भवन्तु लोकाः समस्ताः सुखिनो भवन्तु स्वस्ति.
Okay, now thank you, Satyaji. Now let us recite national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हे जय जय
ధన్యవాదములండి చల్లా చిట్టిబాబు గారు.